Well, here we are again. I guess this is your lucky day. More math problems, trigonometric equations in preparation for test 4 and 5. Let's jump right into it. Our objective here is to solve for theta on the interval between 0 and 2 pi, so within one unit circle. Let's start by isolating the trig function. I'll subtract 2 from both sides and then divide by 3 times the square root of 2. So cosine theta is equal to, well, -1 minus 2 is -3. -3 divided by 3 root 2. Well, that can be simplified. Cosine theta is equal to -1 over square root 2. But the problem that I have here is that in the unit circles that we memorized, I don't know where an x value is equal to -1 over radical 2. Now, you might be able to take a guess as to where that location is, but let me just remind you of a technique that I don't typically require, but it is helpful in this instance. If I've got the fraction 1 over square root 2, and I'd like to rationalize the denominator, that is, eliminate the square root from the denominator, then that's relatively easy to do. We just simply multiply this fraction by another fraction, and this fraction is a form of the number 1. Square root 2 over 2 is just the number 1. So this fraction times this green fraction doesn't change the green fraction's value. It just changes the way it looks. Now, this is helpful for us because if I multiply this out, well, -1 times square root 2 is negative square root 2, and square root 2 times another square root 2, well, that's a radical times itself, and that leaves us with just 2. Now, this is a form of the number that I'm used to seeing. I know where the x value is equal to negative square root 2, and that's in this position and this position. I should say the negative square root 2 over 2. So those are these two coordinates here. Now I can answer the question. 3 pi over 4 is this first angle, and then 5 pi over 4 is the second angle. So 3 pi over 4, 5 pi over 4. This little trick is helpful. Again, not always required, but helpful when some of the solutions don't seem to be typical. All right, now in 28, we finally get to use a calculator to solve some of these. So I'm going to start up my TI Inspire calculator. Remember, each of you do have access to this electronic version of our classroom calculators. You just have to download it from the Software Center on Butler Tech's website. But you could also use a basic calculator as well. So this simple scientific calculator will work just fine. These are all different. So if you're using a scientific calculator on your cell phone, or if you've got a handheld, the order in which you press the buttons might differ slightly, but the main objective is essentially the same. So I'll show both methods for solving this with both calculators. Just remember that if our objective is to find the theta value, in order to remove the trig function from that theta value, we need to use the inverse of that trig function to isolate it. So very straightforward here, theta would be equal to sine inverse of 0.18. Now on the Inspire, super easy to complete that. We'll press the trig key, select sine inverse, and type 0.18 and press enter. Now my calculator is set to radians, which I believe is required for this question. Let me just double check that. Yep, our solution set is in radians. If the solution set is supposed to be in degrees, then make sure that you make that switch. Press the gear button, go to document settings, change your angle to degree instead of radian. So the position that gives us a y value of 0.18 is either 0.1809 radians or 10.3697 degrees. Again, this question is in radians, so I better switch that back. All right, so 0.1809, that's going to round up to 0.1810. So theta is equal to 0.1810. And they are asking for just 2 decimal places, so I'll round that when I get to the final answer. Now here's the problem. The calculator is only programmed to give us one result. And so essentially what it's done is it's given us this position here. The y coordinate at this position is 0.18. But let's not forget that this position over here is also going to have a y coordinate of 0.18. And we have to essentially be smarter than the calculator here and determine what the angle measure is that lands us in this position. Well, if you're aware enough with the unit circle, you'll recognize, well, the difference between here and here is the same as the angle difference here. And this position is technically pi radians. So the position in this coordinate is the angle measure that we just established, 0.1810 radians, less than pi. So if I'm using the Inspire, I'll just type pi. I'm using this key down here in the bottom left-hand corner. Whoops. We'll choose pi and subtract the answer from before. And the nice thing about using the Inspire is you can recall all of these decimal values without the worry of rounding. When I press Control Enter here, I'm pretty confident in this solution to all of its decimal places. There is no rounding that's occurred at this point. In fact, this pi value I think has 15 or 16 decimals built into it. So we're now looking at 2.9606. That's our second solution, 2.9606. And the instruction said round to 2 decimal places, so that's where the 0.18 and 2.96 comes from. Now, if you don't have a graphing calculator, that's perfectly fine. We can do the same thing with a basic calculator. On this one, however, I have to type the ratio first, so I'm going to have to type 0.18, then ask for the trig functions. Now this trigonometric button only has the 3 functions available, so in order to get to the inverses, I have to press this second command key. And by pressing that button and then sine inverse, I don't have to press equals. The calculator automatically gives me a result. But again, you've got to be very, very careful here. This calculator is in degree mode right now, so I need to switch it. And I'm going to tap the degree button, and it automatically switches to radians. I can't automatically recalculate though, so I'm going to have to punch in the work again. 0.18, trigonometry. Second button inside of the trigonometry button calls the sine inverse command, and there's the 0.1810 that we got from the other calculator. So again, the keystroke pattern on your scientific calculator might be different than mine. I think most cell phones operate like this one, but not all handhelds do, and you just have to explore that and be careful with it. Let's try this one next. When does tangent theta equal 7? Well, that's fairly straightforward to calculate. Theta would be the tangent inverse of 7, and according to my calculator, I'm going to go back to the Inspire here. Tangent inverse of 7 in radians is 1.4289 when rounded. 1.4289. Now, thinking of that as a position in a unit circle, 0, pi over 2, pi, and 3 pi over 2. These are our cardinal directions. Pi, which is 3.14, divided by 2 is about 1.5. So in terms of decimals, 1.5 would be this vertical position, and 0, of course, is down here. So when we're talking about radian value of 1.42, we're talking about an angle measure that's somewhere in here. And again, that's one solution. That's the solution that the calculator can and will compute for us. But remember, there's another position that also has a tangent value equal to 7. All students take calculus. Tangent is also positive down here in the third quadrant. And as you recall, to find the equivalent tangent value in the third quadrant, we just have to do an additional half circle or pi rotation. So we'll add pi to The 1.42 solution, this 1.42 plus pi equals 4.5705. 4.5705. And when rounded now to the second decimal point, we see the two solutions that the MathExcel site expected.